wanted to take a minute to clarify the new text 8.7d, which tells us to use the Pythagorean Theorem to find the distance between 2 points, and clarify for everyone what specifically you need to be thinking of as a classroom teacher. That SE does not state to use the distance formula. We actually have a geometry new text that is G2b that actually states to derive and use the distance formula. So in geometry is where they're going to take the concept of finding the distance between 2 points and put it into a formula. In 8th grade, we're just working on the concept. And I think that's really important because many of the resources that we have actually do include the distance formula. But I do not think that's how it will be tested, and I don't think that's what our task is. So when I look at this and I need to determine the distance between 2 points on a coordinate plane, I first need to have those 2 points. I think sometimes they're only going to give you the ordered pairs, or possibly you're going to already have them drawn for you on a coordinate plane. So to help students practice, you want to do both types. So in this case, I have a blank grid. I'm going to go ahead and draw in my own X and Y axis. Maybe you'll draw a straighter line than I do. And I have point 4, 6, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6. I think it's important that you model for students graphing because this will just help you. I'm going to say that this is point A and this is point B. So I'm going to say A. Point B, I have at -2, 1, 2, 3. Oops, positive 3. 1, 2, 3. And here's my point B, and I need to find the distance between these 2 points. I could use some tools that I already have. Oops. Let's fix that. So here's the distance that I need to determine. So to use the Pythagorean Theorem, which is what it states, I need to turn this into a right triangle. So I'm going to model that, hey, I can see how this forms a right triangle when I look at that. And when I look at this right triangle, I now see the distance between point A and point B is my hypotenuse. And here is my right angle formed from a vertical and horizontal intersection of 2 lines. So I have this right angle. A tip that I often use when we use the Pythagorean Theorem is that the right angle is like a boat dock. We color it in and we see across the lake. So this line segment I'm going to say is line segment C. Then I remember A and B, and I'm going to connect this back to, once we have a right triangle and we know the measurements of 2 sides, we can use the Pythagorean Theorem to find the third. So all I have to do is see what is the length of side A. Not point A, but the side A. So I have from here to here, and I have 1, 2, 3. So this measurement is 3. And then this is 1, 2, 3, 4, 5, 6. So this measurement is 6. So if I use my Pythagorean Theorem of A squared equals B squared, A squared plus B squared equals C squared, I'm going to have that the distance of this leg is 3 squared. The distance of this leg, the vertical or the horizontal distance is 6. And then I can just do my calculations. So 3 squared is 9. 6 squared is 36. And that's going to be C squared. And 9 plus 36 gives me 45 is what the square of C is. So to find the length of the side, I'm just going to square root, because the opposite of a square is a square root. So the square root of 45 is going to be an irrational number. So I have the option of leaving it as the square root of 45, or if I want to put that into my calculator, I can calculate the square root of 45 to be, because I know it's irrational, it's going to be approximately, because I'm going to round it, it's going to be approximately 6.7. So that gives me the distance between two lines. That's really the focus that I believe that this text is wanting you to do. You should include some points that are not whole numbers because it does talk about rational numbers, although I think if they do have 2 points, they will certainly have user-friendly decimal values. So if I want to just quickly do this problem, it's the same thing again. I'm going to create my own x and y axis, just because modeling this for students makes them more comfortable doing this. I have a point at 5, 3. 1, 2, 3, 4, 5, up 3. Maybe this time I'll call it something else. I'll say P, and this is Q. So here's point P. Point Q is at 1.5, -2. And here's point Q, and I want to connect this point to here. So again, now all I have to do is draw my right triangle. I could do it that way, or it's a good idea to model sometimes doing it a reversed way where you're putting the triangle on top just so that students have a visual of both directions. So when I want to calculate the vertical distance, it's up 1, 2, 3, 4, 5. So this gave me a whole number. Might even want to talk about that if this is 3 and this is 2, -2, what is the distance between these 2 points? Well, we could say 3 minus -2, which will also give me 5. So although we're talking about concepts that are embedded in the distance formula, we're not actually using the distance formula. Again, this is a conceptual lesson or concept that we're developing for our students. This horizontal distance, though, remember we're starting at 1.5. So this is really a half. So here's a half, and then so I've got 1, 2, 3 plus this half. So this distance is 3.5, or I could put 3.5. So now I'm going to model using the Pythagorean Theorem. So if I decide, here is my right angle, here is my boat dock, and I will see across the lake. So then I know that my two legs are A and B. So if my A is 3.5, and my B value is 5, I can then continue on using my Pythagorean Theorem to calculate this. It's okay, great place to embed using your calculator. You could do it multiple ways. So 3.5 times 3.5, or 3.5 squared, gives me 12.25 plus 25 equals c squared. I can type that into my calculator and I'll get that 37.25 is the equal to c squared. And to the opposite of a square is a square root. So I will square root both sides to undo this math. So c is equal to, and you can leave it like that. I think in this case, because there is a decimal under the radical, that I would probably go ahead and see what would this be, 37.25. And rounding to the nearest tenth, I get 6.1. And to me, is this reasonable? That would be a great thing to ask students to think about. Well, remember, the hypotenuse is always going to be greater than either leg. And since 6.1 is greater than my longest side that I know, 5, that would seem reasonable. Also considering that 6 squared is 36, which is close to 37, those are other ways to think about, is this reasonable? And that gives you the distance between two sides. Just something to think about. If you check the Google Drive under 8.7D, there is a task card activity that you can use, and it has a recording sheet that has blank grids already created for you. Another activity that you might want to try is just giving kids some blank cards that might have the signs already embedded for them. They could have some blank cards where some are negative or positive, and they draw the card and then they roll the dice 2 dice, and then the dice, whatever numbers they get, those are the numbers they use, and they could just create on blank grids just to practice using the formulas. Hope this helps.